All right, we are back. This is the last one. We are looking at chapter 6. The review material from chapter 6. That's on page 14 and 15. There's a couple of problems. The final is 140 points. 40 of them will be chapter 6. And then the rest will be all the other chapters. So you want to go back and look at your tests. At the very end, I'll do a little laundry list of all of the stuff to kind of know. So let's do it. Solve the differential. So dy dx, multiply both sides by dx. And then divide out 4 minus y. So we got 1 over 4 minus y dy, and now integrate. So we do the integral of each, use substitution, 4 minus y, so du is equal to negative dy, and so divide out the negative 1, so negative du is equal to dy. So we're going to throw a negative on there. So we have the opposite of 1 over u du is equal to the antiderivative of that. Oh, here we'll do the plus c1. Antiderivative of that is just going to be x plus c2. Okie dokie. And so now we do the derivative. So that is 1 over y. So that's ln, the natural log of u, which is 4 minus y. Oh wait, there's not a plus c1 there yet until you actually do the integral. There's not a c1. So now there's a c1. And there's a c2. And now we want to fix that up. So that over there and c3 or whatever. I guess we'll call it c3. All right, and now, divide out the negative. And so we have ln of the absolute value of 4 minus y is equal to negative x minus c3. And now we can do e ln, apply e. And so this is 4 minus y. We just bring that down. This is e to the negative x times e to the negative c3. But e to the negative c3 is just yet another constant. So we're just going to call that capital C. This is just capital C. So you got 4 minus y is equal to e to the negative x times c. And now solve for y. So y goes over there, e to the negative x, c goes over here. So y is equal to 4 minus c e to the negative x. And that's it. That was not an easy problem. That was a little... You had to do a little u substitution and the integration and all of this c nonsense. At the end of the day, it just turned into that. Okay, let's look at number 2. Number 2, they just want to know if that is the solution. Well, we can figure that out pretty quick. So, differential equation is this. So that's the differential equation that they gave us. And now they want to know this is a solution. So let's find out. Let's do a rewrite. We'll do y is equal to 2x squared plus x squared e to the x. And so when I look at this, I need y and I need y prime. So let's find y prime. So we've done that, right? That's going to be 4x plus x squared e to the x plus e to the x times 2x. So remember, derivative of the first, derivative of the second times the first, whoop, plus derivative of the second times the first. Okay, a little product rule there. So you don't get to forget anything like that. All right, so what is our y prime? Let's clean that up a little bit. So 4x plus x squared e to the x plus 2x e to the x. So now let's sub in this there and this there and see if it comes out to be that. That's kind of the big reveal. So instead of x, y prime minus 2y equals x to the 30x, I'm going to leave the x's, so x, but now y prime, I'm going to put in 4x, x squared e to the x plus 2x e to the x minus 2 times, and put that in there, 2x squared e to the x, and see if that equals x to the 30 to the x. So a bunch of distributive property, 4x squared plus x cubed e to the x plus 2x squared e to the x minus 4x squared minus 2x squared e to the x. Does that equal x to the 30 to the x? Well, those go, and those go. Yeah. X to the 30 to the x equals x to the 30 to the x. So we got a confirmation. Then y equals x squared times 2 plus e to the x is a solution to the differential equation. Or yes, I guess if it was a yes, no question. All right. Well, let's look at 3. P with respect to t is proportional to 10 minus t. Okay. So we've got dp over dt is equal to k minus t. And what do we want to do? Solve for p, I guess? What exactly did they ask us to do on that one? So it's page 14 in the notes. The rate of changes of p with respect to t is proportional to 10 minus t. So dp over dt is equal to k times 10 minus t. Okay, so I guess we can find p. Let's do it. This would be the separation of variables. So if they just wanted us to separate the variables, we'd be done. That would be it. Because t, k is a constant. But here, we'll we'll differentiate. So P, or integrate, we'll integrate, do the antiderivative. So remember K is just a constant, so U is equal to 10 minus T, so du is equal to negative dt. So negative du is equal to dt. So negative K of U du. So P is equal to negative K of U squared over 2 plus C. So P is equal to negative K over 2 times 10 minus T squared plus C. And that's all she wrote. So if they just wanted us to separate the variables, we could have stopped up there before I differentiated and just right there. But if they wanted it actually, solve out for P. Yeah. All right, let's look at 4. Differential equations. So there was 3. So number 4 says the rate of change of V is proportional to V. All right. When T is equal to 0, V is 20,000. When T is equal to 4, V is 12,500. What is the value of V when T is equal to 6? Okay, so this one's actually kind of straightforward. Differential equation dV dt is equal to K times V, which means V is equal to C e to the KT, or V is equal to V naught e to the KT. This is likely what you're going to see like in a physics thing instead of a C. They'll use V naught. They give us V naught actually. Okay, so when T is equal to 0 and V is equal to 20,000, we know that V naught is equal to 20,000. Because basically, if you put in 20,000 here and 0 there, that C is equal to 20,000. So you can just kind of go right to there. We're good. So now T equals 4, V equals 12,500, V naught is equal to 20,000. So 12,500 equals 20,000 e to the k times 4. So divide out the 20,000. E to the 4k. And then what does that reduce to by 50, 5/8? So now to take the natural log of both sides, ln 5/8. And again, when you do ln e to some power, you bring that power down. It's just 4k. So 1/4 ln of 5/8 is equal to k. And so now if we write it, let's pretend like I don't have my calculator. I'm not using a calculator. So that is my k. So now if I rewrite it, I've got V is equal to 20,000 e to the 1/4 ln of 5/8 all times t. So if I didn't have a calculator on the test, this would be what I would put down for an answer. But then they want me to go one step further. They want me to, I have the model now, and now they want to know what is it when t equals 6. And so if I don't have a calculator, this would be the answer I put on my test. 1/4 ln of 5/8 all times 6. And you don't even have to do this. You could make it 6/4 and then make it 3/2 ln, but this is fine. That would be fine. Now, if you do have a calculator and you want to know, that's approximately 9,882. 118. Okay. And I don't think they gave us context in the problem. So units or what have you. All right, on to number 5. Okay. So 5 is a little more familiar. Object falling on Earth falls at 32 feet per second per second. So given the velocity of t is equal to negative 32t plus 96, find the general position. So remember SVA, when you go up, that's the antiderivatives. When you go down, that's the derivatives. Or integration, we might have written that as integration. Going that way. So what does that mean? Letter A, find the general position. So that's S. So velocity given as negative 32t plus 96. S of t is going to equal the integration of the velocity dt. So that's going to equal the antiderivative of that, right? So t squared and then negative 32, but then whatever that is divided by 2, right? I added 1 and then divided on the bottom. And then plus 96t plus c. So S of t is going to be negative 16t squared plus 96t plus c. All right. So there we are. Letter B. When S of 0 is equal to 2, give the particular solution. So that just means I put in a 2 and a bunch of zeros. And now I found C. And so now that I know C, the particular solution is negative 16t squared plus 6t plus 2. So we got the general solution, we have the particular solution. C, find acceleration. Okay. So acceleration, A of t, that's going to equal the derivative of the velocity. It gave us the velocity right there. Derivative of that is just negative 32. So A of t is equal to negative 32. And then on to number 6. And actually 6 is going to be cut a little short. It says don't integrate because to integrate that one, we would have to use partial fraction decomposition, which is something you might have picked up in like advanced algebra or pre-calc, but you might not have. And so that's going to be revisited in Calc 2. but we're not going to do it in Calc 1. So we can do the prelims. So dn dt is equal to k times n times L minus n. So both k and L are constants. All right, so you don't have to worry about dl or something like that. It's dn dt. All right, so now all we do is k n l n dt. And now we want all the n stuff over there. So all the variables with the n, you're going to get divided out. And this is where you need partial fraction decomposition. And we're not going to go over that on the last problem or the last review. So from there, we would want to integrate. But like I said, that would require us to split this up with partial fraction decomposition, and we're not going to do that. So that's where she stops. And that's it. So on the final, there won't be one where you have to do partial fraction decomposition, that's for sure. So let's erase that one. And these are all things that you're going to have to do on the final. So it's 140 points. There are limits. Limits going to infinity. Derivatives, of course. Chain rule, product rule, quotient rule. Make sure you know all those. All the derivative rules. Integrals, again, kind of obvious, right? U substitution. Heck, we just did U substitution 3 times in this chapter. Natural logs. Know your e's, right? Your e to the x's. E to the x's with integration and derivatives. Same formulas on the sheets that have been on the previous tests. You can review your tests. You go and review tests. Click on the test and do review my submission, and it'll show all the stuff I wrote on it. And you can still Google Meet with me, and we can go over stuff if you're stuck on things. So same formula is given as in the other sheets. Remember from chapter 4, relative max, relative min, the extrema, right? Concavity, and how to showing the steps for that. To know if it's a max or a min. Know about removable discontinuity. Remember, that's a whole. And then unremovable, non-removable discontinuity. That's like asymptotes. And discontinuity holes, okay. Okay. And all the stuff from chapter 6. So yeah, look at all your old tests 140 points, 3540 of it will be the chapter 6 stuff that we just went over. And here, I'll do a little flip book for you for the chapter 6 notes and their last review here. And then after we're done, here we go. Page 2 is right there. Page 3. Page 4. Page 5. Page 6. Page 7. Page 8. Page 9. Page 10. Page 11. Page 12. Page 13. That one's kind of a mess. Number 2. And then 14 and 15 are just the written things. So here's the review work that I just went over. Page 1, that's number 1 and 2. Page 2, that's number 3 and 4. Page 3, that's number 5 and 6 in the laundry list of stuff that is on the test. And thank you for all of your kind patience. I will show you why I tripped over the thing here. I've got a lot of stuff out of sight of the camera. I'm walking around like BB-8. I scratch built him. I take him to Children's Hospital. Oh, and this year we took BB-8 and here, let me reposition this. So that's C-3PO. That's BB-8. Over here on this side, I got R2-D2 and Darth Vader. So kind of stepping around things. There's Darth Vader. R2-D2. So there's not a lot of clearance between R2's feet and my tripod. That's why I kind of hit it. And BB-8, and then here, this guy's new. This is the first year I took him to Children's. He turned out pretty good. So BB-8 was scratch built, but this is Yoda. I built him, and like this is just stuff from Walmart, like a little planter thing. And so I bought him. He came, I had to paint him and put hair on him. And put the clothes on them, and I built the base. And then, yeah, I went to Walmart and bought like fish tank stuff and just painted it like silver and stuff for that. But Yoda, he was okay. There were a few kids, little kids that really liked Yoda. There were a few kids that didn't want to stand with their back to him too. But I take the droids to children's usually a couple of times a year. So far Darth Vader's been too scary, so we're gonna maybe for Halloween, I'm gonna see if they want Darth Vader to come for Halloween. So anyway, thank you very much for all the hard work. I know this is a lot of material, and we'll maybe see you later in life.